Hi Jefferson. Today we are going to be doing our third and final lesson this week for distant learning. You should be watching this video and completing this lesson on Wednesday, March 18th. Tomorrow, March 19th, is a study day for you, a day for you to email me questions if you need any assistance. And then Friday, I will post a quiz on Google Classroom for Module 11. So let's begin by looking at our interactive notebook. While I was reviewing our interactive notebook, I actually ended up not liking the way I had set it up. So instead of having the first entry, page 1, second entry, page 2, I changed it to the module number. So this is 11.1, 11.2, we had 2 examples there, and 11.3, we're going to have 2. I went ahead and I cut a piece of paper, a blank piece of paper, and then I glued it and I just renumbered them. If you are fine with the way yours is numbered, that's great. Once again, this is your own reference tool and study guide, so you can do it the way that you want. I am going to start with 11.3, angle similarity, and that's going to start on page 4. Here it is, page 4, and the title of this is angle similarity. I am going to turn my page over and we are going to look at something called the angle similarity postulate. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. Let's go ahead and copy that down in our notebook. And we are going to begin with looking at example number 1. Explain whether the triangles are similar. The postulate states that 2 angles must be congruent in order for them to be similar. In this case, we have one angle that's congruent, angle B and angle E, but the other 2 angles we don't know. We have a 45 here and an unknown. We have a 35 here and an unknown. If you think back to our lesson yesterday states that the sum of the angles of a triangle are 180 degrees. So these 2 plus the third angle must equal 180. These 2 plus this angle must equal 180. So I am going to write that as an addition problem. A, B, and C. A is 45 degrees plus B is 100 degrees plus the unknown angle must equal 180 degrees. Our second triangle, D, is our unknown, plus 100 degrees plus 35 degrees is equal to 180. Now we can already see that so far we have one angle that is congruent, and once again we need to have 2. So let's do some addition. 45 plus 100 is 145. 145 plus what number makes 180? That number is 35. Okay, let me double check my work. 45, 50, 60, 70, 80, 180, check. Let's do the same thing with this bottom. 100 plus 35 is 135. 135 plus what number is 180? That's 45. I'm going to double check my work. 45, 50, 60, 70, 80, 180 is correct. So these 2, yes, indeed, are similar. Okay, I'm going to give us a happy face. Well, let's move on to another example. We'll do question number 3. 2 more triangles. We have a 58, a 70, a 70, a 49. Once again, we have 2 angle measures that are already congruent. We are going to set it up as an addition problem. NOP. N is our unknown, plus O is 58, plus P is 70. Once again, this must equal 180 degrees. Q in our second triangle is our unknown. The R is 70. The S is 49. And this needs to equal 180 degrees as well. So we are going to do some math. Okay? 58 plus 70 is 128. 128 plus what number is 80? That would be 52. 50 plus 50 is 100. 110 plus 70, 180, correct. So far we have 2 angles. Those 2 are congruent. Let's see if we can find another 2. 70 plus 49 is 119. 119 plus what number is 180? That's 61. Let's see if my math is correct. 60 plus 40 is 100. 1 plus 9 is 10, so that's 110. Plus 70 is 180. That is correct. So this is not similar. You only have 1 angle measure that is congruent. Since you do not have a second angle measure, this is not a similar triangle. Okay? Not similar. The first one, because they are all congruent, they are similar triangles. So when you do this lesson, you have a QR code from Dr. Berger that you can watch, and we are going to continue with the similar triangles into another lesson. So these triangles are actually dilation, something that we learned about, I want to say in September of 2019, and we are going to learn how to find the missing angle measures. Once again, there's a QR code video from Dr. Berger, but we are going to do an example together. We're going to take a look at page 366, question number 6. Okay? I'm going to turn my page over to page number 5, and once again, the title of this is Finding Missing Measures. The same for page 5? Yes, page 5. Finding missing measures. I am going to read the problem to you. Question number 6. The lower cable meets the tree at a height of 6 feet and extends out 16 feet from the base of the tree. If the triangles are similar, how long is this tree? Excuse me, how tall is this tree? I'm a visual learner, so it's great that there is a picture here, and I'm going to reread the question. I'm going to make sure I understand the triangles, okay? The lower cable meets the tree at a height of 6 feet. Here is the lower cable. It is going to meet this tree over here at 6 feet. And it extends out 16 feet, meaning this right here is 16 feet. If the triangles are similar, how tall is this tree? Okay, I am going to solve this problem by setting up a ratio. Okay, finding missing measures, we are going to set this up using a ratio. Once again, this is page 366, number 6. We know enough information about the small tree to solve this problem. Okay, we don't know the information about the big tree. But we know that the height is 6 feet. And it extends out from the base 16 feet. We are going to make an equivalent fraction. That's how we're going to set up our ratio. Okay? We don't know how tall the tree is, so we are going to represent that by x, but we do know how long the base is. That is 56 feet. How do we solve this problem? We are going to cross multiply. 16 times x is 16x. 6 times 56 is, I believe, 336. Okay? We are now going to divide both sides by 16 in order to isolate this variable. And x is equal to 21. 336 divided by 16 is 21. So the answer to this question here is, how tall is the tree? The tree is 21 feet tall. Since we know that this triangle and this triangle are similar, then we're going to use a ratio to solve the problem. Once again, if you have any questions, please email me and I will respond right away. Thank you.